we built a certain way all the way up to the sort of, 1920s. Then there was a shift. It became very, very artificial, incredibly processed, more efficient in some ways, so less skilled labour. But now we're having to sort of go back and look at some of the things we did in the past, because we did things quite well in a low carbon way, in a much more low carbon way than we're doing now. So it's this interesting shift of looking at the past, but also lots of innovation. So it's a mixture of the two. So sort of modernized the past in a modernized way, modern version of the past, I guess.
So how does that show up then? What does that look like? Give me an example.
How does that look like?
Yeah.
What does that look like? So, for example, my projects use a lot of lime plasters, for example, and lime plaster was used. If you have a period property and you take the wallpaper off and you get to the plaster, and if it hasn't been touched, it will be an original lime plaster, and it'll be about 20 to 25 millimeters thick. It'll be nice and thick. So we're and if it's in good condition, we can reuse it. If it's not, and it's had lots of repairs, and there's cement plasters or gypsum plasters all mixed in, then we have to take it off and go back to putting a lime plaster back on as our substrate before we put insulation on there. So I think maybe the surprise is how much effect we can have in terms of reducing the carbon impact by using the materials that we're using, but also the carbon impact of the heating, because 28% of carbon emissions worldwide are to do with powering our buildings, and being able to reduce that massively in a project, I guess there's an element of surprise and excitement over that. We've got a project where we reduced it by 90%. And that's like a really massive, it's really huge.
So is that like a passive house style, or was that? And you've mentioned lime plaster. Is that connected to lime plaster as well?
So we've used lime plaster because it's often the part of a system where you've got, for example, wood fibre or cork, and they end up with a lime plaster as the final finish. I can pick this up.
So this is lime plaster example here that you're holding up.
Yeah. So basically, we've got a cork base, and it could be a wood fibre one as well, which is there.
Yeah. And
that might go straight on an external wall internally or externally. And then it has a build-up of like 3 layers of plaster. So you get a base layer, which usually has a little groove in, and it can be as thick as 5 millimeters thick. And then there's like a mesh that gets pushed into that. And then there's another layer that smooths that out. And that's another 3 or 4 millimeters. And we try and get that smooth. And then if the client wants a really, like a really fine finish, like a gypsum plaster finish, then there's a fine finish that goes on that if it's internal. Or if they don't mind it a little bit more rustic, we can keep that first layer, that smooth layer. So that goes on top of the insulation. And one of the nice things about it is it gives a 1 hour fire protection with it being 10 mil thick. So that's quite nice. The other thing that's nice about using these materials, they people do ask me about fire. Now that I've just touched on it, and they're not, they're natural materials. They will burn, but they have a tendency to smoulder and not leap into flame. And then the lime plaster on top is protecting them for an hour anyway. And we put in plenty of fire alarms. It's good practice to put plenty of wired-in fire alarms. And it's something that people talk about since Grenfell. We're all much more aware of fire.
So just coming back to these materials here and this thing, can I just grab it?
Yeah, sure.
Just grabbing this thing. So, so the cork element, you're saying that will go on the inner skin. So you'll have your outer blockwork.
Or brick wall.
Then you'd have a cavity.
No.
No cavity.
No. Let's think of it in terms of a period property.
Okay.
So you've got a solid brick wall, and 225 mil thick or 330 mil thick, depending on whether it's 2 or 3 bricks. The width of the wall. So it's solid brick, and then the existing wall would have a sort of 20 mil of lime plaster internally if it hasn't been touched since it was built.
Mm-hmm.
So if we're insulating internally, we take off. If we have to take off that internal lime plaster, we take it off. Then we put a sort of smoothing lime plaster back on to get the wall smooth and level. Then we put an insulation board. It can be either, there's a number of materials that you can use, but we have a tendency to use either cork or wood fibre so far.
So this cork here would be used as insulation.
Yes.
And so what would be the insulation properties of this cork when compared to something like a rock wall or a...
In terms of lambda values, they're not that different.
Right.
So the performance is not that different, and it's the same with wood fibre. So we tend to use the cork in more wet areas. So like a bathroom, for example, it's slightly more pricey than wood fibre, and then we'll use wood fibre in sort of bedrooms and living spaces and things, but cork would be where there's a bit more moisture. In terms of, it's good to think of it in terms of optimum performance. It's one way that's good to think of it. And when you're reducing the U value of we want to get the U value down, and a typical sort of people refer to them as 9-inch brick wall, but I don't really work in inches. But 225 millimeter wall is typically the U value is about 2. And if you put 40 or 50 mil of wood fibre, of a wood fibre board or a cork board, you can get down to 0.47 or 0.5. So that's sort of 75% better. And then if you add it, if you make it thicker, so you make it 80 mil or 100 mil, you're only actually ever taking it up by another 10% or so. So the optimum is around 40 or 50 mil, right, which doesn't take up too much space in the room, and it costs less.
And so how does that compare then? So when I'm looking at these two insulating materials, just hold this other one up as well, just so that the viewers can see. So this is a wood
fibre.
Yeah,
yep.
Wood fibre insulation. So how would this compare to a PIR board in terms of the insulation level?
So a PIR board has the lambda value is lower. So a PIR board is supposedly more, will reduce the energy loss more, the heat loss more. I say supposedly because there's all sorts of things with PIR that don't work so well with an existing building. So, for example, these materials are vapor open or breathable, as some people like to say, but it's very confusing. Breathable sounds like it's allowing air through. It's not allowing air through, it's allowing moisture through. And moisture molecules are smaller than air molecules, which is helpful because we want the moisture molecules to pass through and we want the air molecules to stay in so that it's airtight. So so PIR is not allowing moisture to pass through. So that causes a potential problem. The potential problem is that the bricks in the winter get wet from the outside and then they dry out in the summer, and they're drying out in both directions. They're drying out into the property and out and outwards. And you put something that's blocking that moisture passing through, you're stopping that drying out process happening so easily. And then the other thing is that the the PAR is, say, inside. We create a lot of moisture inside buildings, loads, like 4 pints per person per day. It's massive.
Especially in bedrooms, is right, where we spend a lot of time breathing.
Yeah, I mean, it's very easy to think about it when, like, you're in a car and it rains and suddenly the whole place, and you stop the car and the whole thing steams up. Why does that happen? Why is that moist? Where's it all coming from so quickly? It's, lots of moisture is created through breathing. And when it gets through and hits a cold surface, you can get interstitial condensation. So say you've got a PIR board and you might have a gap somewhere, and then you've got the moisture potentially passing through, and then it's reaching this cold surface, and then PIR doesn't absorb any moisture, whereas the wood fibre will absorb some of that moisture and take it back into itself and then dry back out into the room. So it's managing the moisture much more effectively and reduces risks, because you can get unintended consequences if like the workmanship doesn't have to be so specifically perfect as it would be if you're using PIR. And often the workmanship isn't perfect for people. People haven't realised how important it is not to have gaps. Now, one of the things that's really nice about this is they've made this simple for the people who are putting it in. So it's got this nice tongue and groove to prevent there being gaps. The reason why gaps are really important is if you have a 5 millimetre gap in between boards, you can reduce the effectiveness of the insulation by 80%, which is massive.
That's really significant.
And as far as I know, the PIR boards don't have the tongue and groove edge. And the other thing I've been told about them is that they shrink over time. So even if they are put really closely together and totally sealed, there's all sorts of things that can happen in that they could shrink. They might you can get this interstitial condensation, which is a word I find difficult to say, stuck between the brickwork and the insulation. It's got nowhere to go. The other thing which I'm not so keen on is I use Ubicus to it's a software where I look at my build-ups and I can see if there's a moisture issue. I can see I get the U values that we reach, and I basically feed in all the different layers into that software. And one thing that I was never really paying attention to was one side of it is about that talks about the sort of temperature dampening of the material, and that is to do with heat gain. And if you if you compare, for example, PIR to wood fibre, and you put it on the same build-up, you can see that PIR has it's like 6 hours that it's dampening the heat gain for about 6 hours, whereas the wood fibre is more like 12 to 14 and sometimes higher, and that is much more effective because it's a whole day. And then you've got the night for cooling, and you want to get that heat. You want to have it as long as possible to stop the heat gain. So in terms of heat gain, wood fibre is massively better.
So can you just, for those people that are listening that aren't familiar with heat gain, can you just break that down exactly what heat gain is?
Well, I think it's just like the way I like to think of it is... and it's something that's really familiar to lots of people, is like you go into a church, right? You go into a church and it's nice and cool. That's because the walls are absorbing the heat and they're sort of holding it there. And that's what it's sort of slowing down that heat gain. It's just going into the material, and then at night it releases. And that's basically what's happening in these types of material. It's absorbing the heat and then releasing it later on. So it's just slowing down that sort of gain of, of the temperature going up. It's just slowing it down.
So the heat gain would be really, really hot day outside. The sun is pressing against the material, heating up the material.
But it's holding on to it.
And that material is just holding that heat in to say, I'm going to just keep it in.
Yeah.
And because the material keeps it in, then the people inside of the building don't feel the effect of the hot day outside.
Yeah. So our bricks do that.
At nighttime, it just releases it predominantly outside as opposed to inside. So your inside isn't going to heat up overnight.
Well, I think with ventilation, you can help it sort of blow it out into the cool night. It's one thing we have to work very carefully when we're insulating buildings is trying to reduce the heat coming in. Heat gain is something that can be an unintended consequence of a highly insulated building. Because if you think about, say, like if I'm sort of giving examples of constructions that are really easy to relate to. So if you think about a tent, like a tent is not, it's basically, it gets hot very easily in the morning and then it's freezing at night because it's not holding any heat. It's, it's just reacting very quickly to what's going on outside. If you've got like a brick building, that brick is acting a bit like in the church where you've got that sort of big solid stone building. It's absorbing a lot of the heat and dealing with it and getting rid of it more slowly and you don't have the impact of, sort of, it's that thing of dampening. It's just slowing that progression of maybe the heat waves. It's just dampening it down so it's not so intense. I always like to sort of think of it in terms of other familiar spaces to understand how it's working.
And that's super useful. So when it comes to using this type of insulation, I'm assuming now that cork will work the same as the wood fibre.
Yeah.
In terms of the way that it reacts to not just the heat gain, but also the moisture.
Yeah.
And you made reference to the cork being used in a bathroom setting as opposed to, that's the most effective place for it to be used.
That's where I tend to use it, yeah. But you can use them both externally as well.
I was going to ask on the more kind of traditional cavity brick and block construction, does it have space there in a cavity? They
won't go in a cavity.
And why won't it go in a cavity? What's wrong with that?
They need ventilating. So when we put them inside, they're naturally ventilated by the space around them because there's nothing on top of them apart from the lime plaster. If they're put externally, and say we've used it where we've built a timber structure, but we wanted it to look like a brick building, so we put a brick face on the front. We had to give a 50 mil ventilation zone that's ventilated. Or if we've got timber cladding in front of it, we have to ventilate it. So it basically has to ventilate. It has to have somewhere for the moisture to come out and get blown away so it doesn't sort of rot the material. And it's basically similar to like a suspended timber floor where you're always having to ventilate the underside of the house to make sure that it doesn't rot, because they are materials that will rot if they get too wet.
And consistently wet for a significant period of time. Yeah,
but they can get a bit wet. They can get wet and dry out, but generally we want to try and keep them dry. That's the main thing. Yeah.
So do you think that this type of building method will ever become mainstream again, as it has done in the past?
So these materials weren't used particularly. We weren't using these materials for insulation because we weren't insulating buildings. We were just building brick buildings with a lime internal plaster, and then they were highly ventilated by all the gaps in the floorboards and all the sort of leaky windows and the air going up the chimney. So they were always very well ventilated, a bit too well. You can feel the wind blowing through them. So now we're making them less ventilated, but then we've got mechanical ventilation coming in instead to make sure we have enough good quality air. It's a modernized version. It's very niche at the moment. So if you compare, if you like to know what the market share is, it's tiny. It's 1% at the moment. So that's how niche it is. I'm on a mission to take it up to 2 or 3 or 4. That's, I want to see it get, I think I want to see much wider adoption. Now, that might happen, if you think about, I like to think about it a bit like sourdough bread. I love to have ways of thinking about things that people can relate to. So if you think about how bread became more and more and more artificial, became more and more, went towards the sort of white sliced bread, and it got more and more refined, mass produced, but it became something that is very inexpensive, but also not really very good for you. There's not much in it that is nutritious in a slice of white bread. And then artisan breads started coming back, and people realized, but you have to have the money for it. That's the problem. So this is more like sourdough bread. It's more expensive. You need the money for it. But it ultimately is much better for you. You can maybe use less of it. You don't have to have it at the really thick. You don't have to put in 100 ml. You can put the 40 or 50 ml and get that maximum impact. But yeah, I think, and I was thinking about it myself, I grew up with a sort of quite bohemian parents, and my mum made our own. She made bread, so I never grew up on white sliced bread. So she made bread, and I always ate brown bread basically, and so for me it's difficult to. I mean, I'll eat a bit of white sliced bread toast. It's much nicer toasted, but I'm not. That's not what I'm drawn to. And it's the same with this. It completely lies in it's the sort of same value system of being more natural, tapping into nature, being more healthy. It's better for it's not only better for embodied carbon, which is then better for the planet. It's more healthy to live in the spaces that are constructed like this. So my hope is that with more mass take up, it will become like, how you can get the artisan breads in Sainsbury's, and you can get them in Tesco's. You can get them everywhere now. My hope is that instead of it being this completely niche thing, that the bigger companies will start to adopt this and have their own range because they'll see the value in it. That's what I'm hoping for.
That would be a wonderful thing, wouldn't it? If the big volume house builders have got an offering that has kind of your sourdough offering, but within the housing industry, something that is not mass produced and low in terms of value and quality from the human perspective, being in there, because there is a significant difference being in a building which is constructed out of natural materials. And I know that we've touched on moisture. We've also touched on heat as well, and heat transfer. But there's also, from a sound and an acoustic point of view, is a difference from the air quality.
Massive difference.
There's a huge difference there as well.
Yeah, so sound, we often use sheep's wool. So here we've got a bit of sheep's wool.
Yeah.
So we often use sheep's wool in our partitions.
Yeah.
Partly because often the partitions might be next to a space that has more moisture in, like a bathroom, for example. And wool can absorb moisture and perform just as well. It can be used in insulation. We use it. It's interchangeable. So I've got a whole load of flexible insulations here. I've got, I think both of these are hemp.
Yeah, it looks like hemp to me.
It's when we put this in a recent project, when we got the hemp insulation, it smells like a barn. It smells like a sort of a field, or like you've gone into a barn in the countryside.
Yeah.
And it was really lovely. We went into the house and it was like, oh, the whole house smelled like a barn. It was really nice. And then there's flexible wood fibre one as well. So they can all go into partitions, or if you have a timber frame build up, they'll go between the studs, or you're insulating a floor, they can go between the joists or between rafters in a roof. So they can go in those places where you want to fit them between two timbers. And they're all interchangeable really, and they're all good with acoustics. But you might want to use them for, different reasons, might make you use one over another.
When you say it's interchangeable, are you saying that you can use it for its insulating properties, and then you can also use it for its acoustic properties? Exactly.
And so you can use any of the flexible ones in those locations. It's just you might choose them because of cost or looking at water, or it might be that you want to support like the wool is a waste stream, or you might want to support a hemp insulation because it's grown in the UK, and it's interesting to support that industry, or for example the wood fibre one I've used a lot because it's been part of a system, timber. It's a whole system that I'm sort of tapping into, and it will have the flexible between the timbers and then a solid wood fibre board on the outside. That's when we're constructing a new wall. So they all, that we use them for different reasons.
So you mentioned PIR and how PIR will reduce or shrink over time.
That's what I've been told.
What is the shrinkage when it comes to things like wool and hemp?
I've not heard that they shrink, and also especially the ones that are put into between timbers, they're sort of pushed in so that they're sort of pushing out to the edges a little bit. The main thing you want is that there's no gaps, and that's
snug fit.
A snug fit, and that's what that's some of the learning that needs to happen in the industry, is that care with putting insulation in is not something that's been really thought about until more recently.
Yeah, well, I think the difficulty with that is that the people working on the site are paid for the amount of bricks or blocks or stone that they lay, and the insulation is a pain because they're not getting paid for fitting the insulation. So there is a rush job that's done for the insulation if it's in a cavity. Probably not so much for insulation on a solid wall, but definitely when it comes to cavity, insulation is a pain.
Yeah, I don't like using cavity wall construction. I don't use it, in fact.
Why is that?
That's one that I think is it's very hard to retrofit. It's one that I think is old-fashioned construction now, although it's modern construction. In my mind, it's like we've done that and we need to move forward from that. There are when we've done a brick wall, when we've done sort of solid construction, which isn't timber, we've used polytherm bricks, which have basically. They're both insulating and structural, and they've got holes running all the way through from top to bottom, which are creating the insulating properties. And so it becomes this solid piece that goes in. I'm not very keen on cavity wall construction. They don't tend to be the ones that are promoted by the natural material suppliers, who are the ones that I go to. That's not usually a cavity wall system within their systems that they're talking about.
Interesting. And I think that speaks very much to the concept that you made mention of before, which is historically it was a solid wall build. Then there was a shift to predominantly it was a cavity. That cavity wasn't filled. Then it started to be filled. And it sounds like from what you're saying now is that the thinking is actually when it comes to retrofit, it's really difficult, if not impossible, to do a retrofit on a cavity. But with solid walls, there's a lot more flexibility and there's a lot more options that you have.
No, you can retrofit a cavity wall. It's just the inclination is to put insulation in that cavity, but that can have unintended consequences, because what happens when you fill the cavity is you can get water bridging across from one side to the other where it wasn't before, and it just seems to have more issues. When we're looking at insulating cavity walls now, we're putting a system that's an internal wall insulation and leaving that cavity it's a bit like the brick wall that I was talking about, where we had a timber frame and we had the ventilated 50mm cavity, and then we had the bricks. We just leave the cavity and the bricks on the outside and insulate internally.
And that's why I say that retrofitting with a cavity wall is, and you may not agree with me here, but we'll see, it is not really retrofitting a cavity. What you're doing is you're treating a part of a cavity wall as an external wall or as a solid wall, and you're doing something else because you don't know and you can't see inside that cavity, and the risk is damp. That's effectively the risk.
Yeah, so you get that is the risk, and the risk is water traveling across. So you can, we've looked at doing that, and you can refill with these little beads, or you can refill it with there's glass beads that you can put. So there's either sort of polystyrene type beads that can go in, or I think they're called EPS beads, or you can put in there's a foamed glass bead that you can put into cavities, and I actually prefer that one because it manages moisture a bit better, and it doesn't wick moisture.
But using the beads or using blown fibre, is that giving you the certainty that you need that you're not going to get that water transfer?
Well, I feel more nervous about it because it's basically this. You get the certainty that what I've been told is the people who are coming to install it, they will be the ones who are giving you the certainty, but they want to do that installation and make the money out of the installation. So I don't feel that comfortable with that. And from talking to, I talk to quite a lot of the suppliers that I go to have really, really good technical support, and their advice, one of them studied building physics, and the other one has a huge amount of experience, and generally their advice is to sort of not really, nobody feels very comfortable with the cavity being filled in the way that dealing with a solid wall and you're insulating either inside or outside. We've seen that there are risks, but they just feel lower. It's just the sort of moisture management, and there's like a lot of people have put little monitors to test how they perform, how, like, for example, wood fibre performs at that junction between the brickwork and the wood fibre, and that has tended to surpass expectations. Like the wood fibre dealt with moisture much better than was expected, and that's nice. It's nice. It's nice to have feedback on that. Because if you put it into the calculator, like the Ubicus calculator, it's showing lots of moisture at that junction, so it's a bit frightening. But when it's run through a WFI calc, which is over 10 to 15 years, it's looking at the temperature going up and down and being winter and summer over that whole period. Then they look at how the moisture performs in that time, and it passes. So,
when was it that you decided that this was the road that you wanted to take within architecture? Because I know you trained initially as an architect, but I'm just wondering here where you became really passionate about materials, really conscious about how those materials are used and the benefit, not just for the building, but for the people that are using those buildings.
It was in 2015. I stopped. I had a benefit of a pause, let's say. So I stopped when I had kids, and I didn't practice, apart from doing a few sketch schemes for families. I didn't practice basically between 2003 and 2013, so about 10 years. And then when I came back into it, I wasn't really sure which way I wanted to go. We'd lived in Jamaica for a bit, and I did a project for somebody who was out there, I think in 2013 or 14. And I'd always been interested in environmental values, and there it's all about cooling. How do you create the building so that you can cool it naturally? So I was looking at orientation, about wind routes through the building, and about shading with trees, and how you optimize for cooling. And so I always had interests along those lines. But in 2015, my partner was away, and I watched a documentary on climate change, and it was the first time I'd really engaged with it. The kids were a bit older, and so I wasn't focusing on them quite so much. And I was sort of finally able to look outwards, and I looked outwards, and I was like, didn't like what I saw, and was very surprised to learn from the show that it could be as quick as 30 years. I hadn't expected it to be so quick. I thought, I knew that there was something happening, but I didn't think it was a quick thing. I thought it was way off in the future. And at that point, I was like, my kids are going to be in their 40s, or one of them would, the elder one would be in his 40s, the other one late 30s. And I was like, it was just that I realised it was far more urgent. And then a couple of weeks later, I went to Future Build, and where I met you, actually. Well, I didn't meet you, but I saw you talking to people. And I'd already been going to Future Build. It wasn't like, it wasn't that I wasn't interested in this stuff. But I came across the Retrofit Academy course, and they explained that people were insulating buildings, and that it was having an impact on it would have an impact on our sort of carbon targets. I didn't really know about any of this stuff at the time, but they explained, you could massively reduce the energy consumption of a building through retrofitting. And we'd lived in a super cold house. We'd moved from it by that point, but I'd had an experience of a house where it was hard to heat. We had a conservatory that was sort of, the kitchen was right open onto this conservatory, which was built off a garden wall, and it just, holding the heat in that space was very hard. So I sort of tapped into the idea of, one, spending less money on keeping a building warm, and two, the effect that it could have overall in terms of helping with the climate issue that we have. And there was a little competition for it. You could put your name and on your business card and post it in to see if you could win. the course for free, which of course I tried, but I didn't. But it was £1,000, and I was like, I didn't have the money, but I was like, I have got to do this course. And I remember a few people saying, oh, why, you haven't got the money, don't do it. And I was like, I don't care. I'm going to do it. I'm going to find a way of doing it. And I was so excited to start that they already had one of their courses that had started before Future Build that was over in Milton Keynes. And then the course that was in London was going to start in a few months. And I was so excited to start. I actually started the one in Milton Keynes and then, and then carried on and finished it off in London once those ones had run out, because I didn't want to wait. I just wanted to start straight away. And I was one of the most sort of excited people in the room, asking loads of questions.
So that was a change for you, 2015, now 2025. The future for you is to try and take that 1% niche to a 2%.
Yeah, or 3 or 4. Let's keep doubling.
That is great.
I want to see it taken up on a much wider scale. I'm developing more and more expertise in my practice to do it, and we don't just look at the materials that have that we've been using. I like to look at new materials that are coming out. For example, this one, which was, I don't know if you saw it when you were at Future Build. It's called
Wetex. No, I didn't see that. No, I was at Future Build just solidly speaking to people. That was all I was doing.
Yeah, well, this one is a new one, and in fact, it won a prize at Future Build for the new innovation product. And I'm looking at potentially using that in a project. And that they also had this mycelium one, mycene.
Okay.
Interested to see how that could go into a project. I think it's, I think the people who are coming up with these ideas, one, it's really exciting. And it's exciting to sort of try them out, but also they need support. They need support for their business to get going, because they're doing a good thing. Like Wetex is made out of a waste stream, so it's made out of waste. It says natural straw fiber, and I think some of it is like the straw that comes off wheat, for example, which is why it might be called Wetex. But they're using the waste material from farms.
From a harvest, yeah.
From a harvest, which is brilliant. I don't think you can get better than that, can you?
Happens every year, right?
Yeah, it happens every year.
It's probably just the way that my mind works.
Like Weetabix.
That's where I was going. Where I was going. Weetabix. I could.
Yeah, it's a bit like Weetabix, but why not? It will keep in people's minds, I think.
Yeah, I think so. That's good. Good. Well, it's been great having you on the podcast and going through all of the material types, and as well bringing the samples along so that the viewers can see it. For those people that are listening, I guess they'll just have to. There's only one way to see it, right? Is to go onto YouTube and find it out. But this is absolutely great, and I'm just wondering here, just as a parting invitation. 2 questions. One is what is it that someone can do to support you? And the second is, what problem is it that you are trying to solve for a potential customer?
Okay, so to support me, hire me. It's a simple answer.
How would they do that?
So I have a website, so Enbee Architecture and Design.com. We do projects from concept to completion. We like to guide our clients very carefully, more and more, especially since the massive price rises from 2021 to 23, 24. We are very careful at looking at budgets from the outset. so that we want to guide our clients to be able to actually build the project. So we start with that. We start with a questionnaire and looking at their budget. And then if it matches what they want to do, because sometimes the budget can be way off what they want to do, then we're able to take it the next step. And we do a lot of work with them on their brief, really understanding their brief. And then eventually we take them through all the stages, the RIBA stages, from stage 1 through to stage 5. 6 is sort of more in use, where we come back and help out if we need to. But we concept to completion, and the clients that I get excited about, and maybe they get excited about working with me, are really interested in innovation, and they're interested in trying new things, and they get the whole environmental thing. They want to do something that's out of the ordinary. That's I want to do things that are out of the ordinary, and if we match, that's brilliant. And I'm also looking at there's a couple of materials we didn't talk about. I don't know if we have time to talk. I just would quite like to mention clay. Clay, there's some 2 funky colours here. So we've got coloured clay. You can see them there. They are they're very nice with moisture as well, because they absorb it. They're made out of just the earth, and I like using them as a final finish. So I thought I'd mention them. And the other thing is to mention is that reusing timber is really important, because there's an amazing stat that I've got from Hattie Hartman's materials book, which is when a tree grows, it absorbs 1.64 kilograms of CO2 equivalent out of the atmosphere, and then you put it in the building, and it gets used and it gets held in the building, and that's great. So that carbon is staying in the building. At the end of use, if it gets reused, you use 0.25 kilograms of carbon to reuse it, or carbon equivalent. And if it's burnt, the exact same amount of carbon is released back into the atmosphere. But if it goes into landfill, it multiplies up, because it turns into methane, and it becomes 41 kilograms of carbon. So it goes from 1.64 to 41. So reuse of timber is super important. So I just wanted to mention that.
The big issue with this is where timber gets ordered to site, more timber gets ordered than is needed, and it just gets buried, because the person thinks, well, it's just all natural stuff, right? It's going to just go back to the earth. It's all fine, but not realizing that huge shift that happens in terms of a pollutant.
Yeah, I didn't realize it was so bad. And also, it's not only that, is that when you're certainly working with an existing building, there's a lot of existing timber that comes out of a building. And I want to see what we can, we've been reusing floorboards and things like that for a while, but I want to look at that even more. I want to go into more depths with that waste stream.
With the timber, that it has less of a negative impact on the environment if you burn it than if you bury it.
Yeah. And hardly any if you reuse it. So you really want to reuse it if possible. And, I was looking at a medieval building was in a town outside, seaside town. And there's this beautiful medieval building with all the original sort of timber structure. It can last a long time. That's like 400 years old. Let's reuse as long as we can.
My final question is, what problem do you solve for potential customers?
What problem do I solve? So I solve the problem of their heat. So I deal with reducing their energy consumption. I solve issues with damp. I help with issues of like moisture control because of all the materials that we use. I solve the problem of maybe the internal layout or making sure they've got enough space. So there might be an extension that's involved. Of sort of thinking about what are 3 words that really describe us. We basically do responsible design that performs. That's our main aim, that it's beautiful, it's warm, and it's healthy. All those things. That's what we're trying to do.
Love it.
We can reduce the embodied carbon from the structural side by, I think, as much as 40%. And that's through using a lot more timber, trying to get rid of steel. If you look at old buildings, a lot of, like when you put an extension in, a roof extension, suddenly there's all this steel that goes in. And the old buildings, they don't have any steel in them. So you can swap it out for timber in a lot of locations. It's just that we tend to want to have these much bigger openings, so much larger spans, which is more difficult to do in timber. So you can reduce the span, maybe not have quite so big openings, or sometimes we use flitch plates. So you've got a sort of steel plate that's sandwiched between 2 bits of timber. So that's one way to reduce it. We're trying not to do concrete slabs. We're trying not to do too much underpinning, so we try and reduce that. Trying to do suspended timber floors, and the recent one that we did together has screw piles in, and then it's a suspended timber floor on that. And then we've got quite a large span in the extension, but we have got a timber column that comes down that helps manage that large span. So accepting a timber column every now and then, that helps. We haven't got any steel structure in the upper part of the building, so we've done it all in timber. There's just it's really good to get a structural engineer who's on board with reducing the carbon in terms of the structure. That's really important, because the carbon that I think concrete is about 8% of the world's carbon is through concrete, so it's massive, and steel is 3 to 4%. That's really huge.
Significant.
Yeah.
Good. It's been great having you on the podcast today. I appreciate you coming here and sharing your wisdom, your passion, and your business. Thank you.
Thank you for having me.
Thanks for watching to the end. I think that you'll like this, but before you do that, just make sure that you've commented and liked below, and also that you subscribed.